Let me just post the link really quick, everybody. There's that. Alright, there we go. Cool. So let's do assignment 6 today. I got main already open. I'm just going to copy and paste that here. And then I need to make a header file for the other one. So, new item, header file. I think it was just called bignum.h. Should probably zoom in a little bit. There we go. And then we'll just copy and paste this one. Right, so that says no string. Let's just include that then really quick. I might throw out these functions as well. Yeah, I'm going to throw out the car to int and int to car one. And this part here, car r to long to car r. I'm going to keep everything, I'm going to, ooh, whoops, that was a mistake. Where am I? Alright, we're up here now. I'm going to throw out everything except for the long to character array. That one I think will help. Everything else I don't think I need. So I will need to, but it uses it. Alright, well. Okay. So this uses the int to character one, and that's it. So I can delete this one. And then we have this other one up here, which I can delete. I'm just going to do this to make it a little bit easier to read later. But I've decided I think those are really, this was the only one I wanted to use just because I think it makes things easier. Everything else can potentially lead to some issues, so I'm going to get rid of it. Let's uncomment all the operators. Right, and then I'm going to, we'll just write the constructor here, I guess. Normally I would write it in main, but maybe just to make it a little more organized, I'll write it here. Okay. So I think that takes care of everything that I need for setup, right? Oh, no, I have this this bignum file. Let's move that really quickly into our directory so that we have access to it. Alright, now I think we should be good. So we have all the operators here. I guess I'll write the constructors first. So we have, what, 4 constructors and a destructor? I think it's kind of important to do that, so I'm just going to go over here, copy and paste that. So you have the default constructor. Excuse me. I guess I need to quantify it. We'll throw that in front. And then I'll just copy and paste it and throw it on these 2. I think that's the right syntax for that one. Let me just make all the bodies for these so I don't have to do it later. Alright, so we have the default constructor, which the bignum has 3 fields that it has to worry about, which is digits, which is a character array of all the digits, the length, which is the length of that array, and then the thing that tells whether it's an invalid number or not. So I noticed that a lot of students didn't set all 3 every single time, and I really think you should try to initialize as many things as possible when doing a constructor. So I'm going to set all 3 of these if I can in all of them. So for the first part here, I'm just going to set, if we do a default constructor, then we don't really have any information to base anything off of, so I'm just going to set the array to null, the length to 0, and the invalid number to true. So by default, don't allocate an array. We'll set it to null, make length 0, and number invalid. So we'll just say it's an invalid number if we didn't specify any sort of specific way to construct it. I think that makes the most sense, but really you could do a lot of different things on this and it would have been alright, so long as you remember how you did it and use it correctly after that. So the next part here we have string number, and really all we should have to do here is take this string and throw it into the character array and then just record that. So I'm going to set the length first, and I'll set that to number.length, which is a member of the string class, so that will just get the string length. And then I need to actually allocate the array itself, so I'll take digits and set it equal to a new character array, I guess. Since it's a pointer, that's fine. And we'll set it to be the length. So allocate an array to store all of the characters into. And then I guess I could use the string copy function here, which a lot of people did, which is fine, but I'll just do it myself since I don't think it's too much work here. So we'll just say for int I equals 0, I less than length, I plus plus, and then we will copy each character from the string into our character array. So copy all the cars from the string to our array. That should take care of that one. Oh, and then I should set the, what's it called? Invalid number equals false. So we'll say it's a valid number if we successfully read it. And I could do more error checking and make sure that the string itself is actually a number string and doesn't contain anything that's alphabetic or, you know, isn't alphanumeric at all. But I think this is alright for the time being. We're just going to assume they're using it correctly. Now this one takes a long and then converts it. So this is the only reason, this constructor right here is the only reason that I kept the helper function. So I want to use this long to char array, which will convert the long argument to a character array, and that just saves some time if we wanted to be able to use this constructor. So I think I will use it. So we'll say long to char array, and then I will use, so this doesn't have a name yet, right? So we have an unsigned long integer, we'll just call it number again. And so I will convert that number to a character array using that function, and then we'll just assign it to digits equals that. Does it return a pointer now? It does. Okay, so that's pretty easy. My work there is done for us already, and then we'll just say, we need to find the length, huh? So we'll have to do that on our own. We'll set invalid number equal to be false. So this number is valid. Alright, and then I suppose we'll have to find the length of it ourselves. And so I saw one way that a lot of people did it was they just did toString of the number and then used that to do everything, which I guess we could have also set digits that way too, and perhaps that would be easier. In fact, you know what, let's do that. Let's just directly say that we will call the big num constructor that uses a string, and we'll say toString, and then we'll use the number. And I don't think this needs to be a compile time constant, so that should be alright. So there we go. One line. So what we'll say here is reuse the string constructor and convert the number to a string. Maybe I'll do that. So we convert the number to a string first, and then we just feed it into the big num constructor that takes a string, and it will just do all of this code up here where it takes the string and figures out how to construct it based off of that. And we saved quite a bit of time writing that, so I think that was good. And reuse the string constructor. Which means that I don't need any of these methods up here, these functions. So actually I'm just going to throw out all these helper functions all together to save space. There we go. Did it all by ourselves. But I think some of those may help if you were having a bit of trouble actually coming up with a way to set up these things. But anyways, there we go. Now we have this one, which is the copy constructor. And it's kind of important that we do this one because C++ does some strange things with copy having trouble speaking copy constructors. So it's kind of important that we set this one up. But really all it should do is just copy over all the stuff from this original big num and then make a new one based off of it. So what we'll say is that we need to set the length equal to original's length. Copy the length, and then we need to copy the array and the invalid number. I'm going to do the invalid number first because it's one line. Not invalid number. Copy the invalid state. And then we actually have to go and copy the character array itself. So I'm just going to say, for safety's sake, if the original dot digits does not equal, actually let's say if it equals null, then we want this one to also be null. And the reason I do this is just because if it is null, then we won't be able to go digit by digit and copy it over, because it's just pointing to nothing. So I think that's safer to do. We'll say if it's null, then don't copy anything. Just set it to null as well. Otherwise, actually copy the array over. So if the original's array is initialized, then we'll copy the contents. So we'll copy every digit individually. And remember that we can't just do digits equals original.digits, because that would copy a pointer and not the actual stuff itself. So if I did that, it would make that whole shallow copy that we talked about, which means that if I end up modifying this specific big num that I'm constructing right now later, then it will also modify the copy, or the thing that it copied from, to make itself. So if I said something like big num A, big num B, and I construct it based off of A, so this here would make a copy of A and store it in B. And if I made it a shallow copy, then any sort of change I do to B would also happen to A, which I don't want to happen. So that's why we have to do this deep copy, where we actually copy each individual element to a new array. So I think first things first, I should actually allocate it, and again, this stuff up here will work because that's really what that did earlier. So that should be fine. And then we're not basing it off number anymore. We have an original, and we're copying over digits array from the original to our array. And there we go. I think that's good for that. And then we have the destructor, which will just say if, oh, this is a thing. So digits does not equal null. So if the array is allocated, delete it. And if it is null, then we don't want to delete it, because there's nothing there to delete in the first place. So I think that one's pretty straightforward. It's 2 lines. And I think that takes care of all the constructors. So we just have the operators. And I think I'll get all the easy ones out of the way first. I accidentally left this code in here just for the sake of making it compile. I think I'm going to do plus and minus last. Those two are going to be the most difficult for sure. So first we have the outstream operator, which prints to the outstream here, out, and then it will print the num there. So I think the first thing we should do is check if num.invalidNumber. So if the number is invalid, print an error message. So we'll write to the output stream, and we'll write invalid number, and we'll just leave it at that, I suppose. And then an end line. Actually, no, I think the end line should be handled by outside of the function, so I think that's okay. So we'll say that, and then, oh, whoops. Otherwise, print the actual digits, so we'll just go through the array and print the digits themselves. So again, we're just going to keep writing this over and over again for int I equals 0, I less than num.length. I++, and then we just want to write those to the stream, so we'll just write num.digits sub I. And that should be it. So this will just go and print all of these individual characters to the stream, and that should be it. Right, so the other one was the input operator, which we're assuming we're reading in a string, I guess, which I guess is what we're reading from file as well. So we'll just read in a string, and then we'll make a new big num to return here. So I think what we'll do is we'll say string temp to store whatever the user's actually giving us, and then we will take in from the input stream, we'll take in a string, read it into that, and then we'll say that num equals, see, we're gonna get a memory leak if I don't do this. So if num.digits does not equal null, then deletes num.digits. So delete the old array if there was one. So again, if we want to avoid memory leaks, we should make sure that if we're going to overwrite something, that we make sure that nothing's there if we are overwriting it. And if something is there, then we need to deallocate it. Otherwise, we're going to lose that pointer and deallocate it. At least when working with pointer types, which is what digits is, because it's a character pointer here. Okay, so that should take care of memory leaks. And then we just need to make sure that we overwrite num now. So we'll say that num is equal to, I think I just do a constructor this way, where I say big num, and then we'll construct it based off of temp, and I think that's allowed in C++. Cool. So construct a new big num using, what's it called? Using temp. And hopefully this shouldn't give us any memory leaks, but we'll find out, I guess. So that will just read in a string and then construct a new big num using that string. So plus and minus I'm going to skip for now because I think they're kind of involved, and I'm going to wait a little bit to do that. So equal, that needs to return true if the digits are exactly the same. So what I should not do is just this, first dot digits equals second dot digits. And the reason being is that if I did this, it would be comparing the pointers, which is the addresses of the digits array, which is not the same as actually comparing the numbers themselves. So even if I had the number 1, 2, 3 and then the number 1, 2, 3, if I've allocated them at different spaces, which I should, then we're going to have a bit of an issue. And especially if we're using these copy constructors, which you should be, that actually make a deep copy, then this isn't going to return the correct thing if I just do this. So what I need to do instead is, again, I'm going to end up writing this for loop a bunch of times, but we need to go through the array and then check if they're all true. So int I less than, we'll just say, well, actually I guess I should check first. So if first dot length does not equal second dot length, then we will return false. So if the two numbers are not the same length, they can't be equal by definition. And then here we'll just say, since they're both the same length, it doesn't matter which one you use, so we'll say first dot length, I guess, and then we'll say if first dot digit sub I does not equal second dot digit sub I, then we will return false. So if any of the characters are not the same, the numbers are not the same. And then at the very end, if we make it through the for loop, then we know that they are equal, so we'll return true. Right, and then so we have this other one here. I'm just going to take this, so not equal. Quite frankly, I could just do this again, so we'll just say return first equals second, And then I'm just going to take this and write a not in front of it. And there we go. So we'll say just return the not of the equal operator. And again, I've reused code, so I don't have to write too much. And there we go. That's taken care of. So those are good. And now we have plus plus and plus plus. So this one's the prefix and the postfix. And really, these are going to both do the same thing. The only difference is the order in which they're executed by the compiler. So the prefix has very, very high precedence. It gets executed pretty much first out of all the operators, and the postfix gets executed at the very end. This is backwards. I hope that wasn't confusing to anyone. Postfix operator is num plus plus, and prefix operator is plus plus num. That appears to be a typo. Hopefully that was clear. I'm sorry if that caused any confusion. Right, so this here, we'll write this one first. Let's see. So we'll just make, I think this is the easiest way. I think most people did it this way too. We'll just construct, I'm going to do this because it's slightly faster. I'm going to construct a big num that's just the value 1, and then I am going to set num equal to, so we'll say plus equals num plus 1. Right, that should be good. And then in C++, it's common to return the object after you plus plus it, just in case you decide to use it. Otherwise, you kind of lose the whole advantage of a prefix operator, I guess, because the advantage of it versus the other one is that you can throw it in the middle of a statement and have it execute before everything else. And I guess that's really the one advantage of a prefix operator. So if we didn't return anything and just made it void, then I guess there wouldn't be much of a reason to write a prefix operator in the first place. Although I can't say I use it too often anyways, but that's why. And then we have the postfix one, which we're just always going to increment by 1. I'm not even going to bother with this integer L. So we'll just take this and we will throw it, we'll just use this one again. So we'll just say return num plus plus. Just reuse, that's the wrong, let's not do that. That's going to infinitely recurse. Just reuse the prefix operator. So if I made it a postfix and accidentally said num plus plus, it would just keep calling itself, and then it would do recursion forever, and we would end up getting that it doesn't work. Right, so that should be good. Takes care of those. The plus equals one's pretty easy. We'll just say left equals left plus right, which is by definition what plus equals does, and then really the same thing for minus equals. And again, this will just reuse the other operators that we've used. So once I write plus and minus, it will just go and use those ones instead. So I will just, for the sake of readability, move that to 1 line. And now it takes up like no space. Okay. So the equal operator, we want to make a copy of the right-hand side and assign it to the left-hand side. Really, this is just the same as the copy constructor. So I'm just going to go and copy and paste that. So we have this copy constructor here, and I'm just going to take it, and we'll do this, and then here, instead of original, the name of it was right-hand side, so we'll name this right. It's really just the same as the copy constructor. And I did not deallocate. Actually, that's a mistake, so I'm going to get a memory leak. So let's make sure that if digits does not equal null, that we delete. So if we have an initialized array, deallocate it to avoid memory leaks. We don't need that in the copy constructor though, because the copy constructor is always called when you make it, so it can't have been actually allocated at that point. So that's why I need it here but not there. Other than that, I think the code should just be the same. And then it really should just be the same for this one too, except this is called value, so we just have to rename the object again. Oh, it's based off a string. Okay, never mind. Never mind. That's a problem. Okay, so let's remove all this. But we still need this part, I guess. If the digits is not null, we need to delete it. Let me remove all this stuff we already wrote. So if we have an initialized array, we'll delete it, and then here we're just going to make a new thing. So I don't think it's legal to just say this equals that, so just for the sake of being safe, what I'm going to do is just use the string constructor and just reuse the code. Otherwise I would call the string constructor and use that, but I'm not sure if we can do something like this equals, you know, something like some sort of number. I tend to think that's a little strange to change the pointer to this in the middle of the execution of a non-static function. I think that's a little dangerous, so I'd rather not do that. So we'll just do it this way. Alright, so that's almost all the operators. The only two that we have are plus and minus, which are definitely going to take the most amount of time. Right, so there were two ways that you could go about doing this. You could have just converted these to numbers and then added them, which I think a lot of people did, and that worked okay for this program, but it's not how we should do it when writing an actual big num class, because that is a thing in a lot of languages. And the reason we use it is because you might run out of bytes if you use the natural representation of numbers that the computer uses. So a integer is 32 bits, which is 4 bytes, and a long integer is 64 bits, which is 8 bytes. And perhaps you're writing something that needs a really, really big number, maybe something in like cryptography or security, where you are maybe writing like RSA encryption, which uses huge numbers to make the key very hard to guess when you actually use it to encrypt things to send over like a network, so that nobody can read what you're actually sending over that network. And so for something like that, you might use a big num class because you need that really big number, and it's not going to fit in those 64 bits that a long takes. So that's the reason why I don't think you should use an intermediary long variable if you did that in your implementation here for the addition and subtraction, because we're not guaranteed that it's going to fit in practice, and we're kind of bound still by a long, in which case we might as well just use a long. But if you wrote that and your program worked, I still took it. That's just something you should consider, is that it might break if you do that. Right, so let's actually do addition the other way, which is we're just going to do addition kind of the way that you might in grade school, where you go digit by digit and add them and carry and all that. So I'm just going to make a big num called result. We'll return it at the end. Now this uses the default constructor, which we said earlier is going to do pretty much nothing. It's just going to set digits to null, so it's not going to allocate anything, which means we don't have to worry about deallocating anything. Sets the length to 0 and the invalid number to true. And so we will just see if we can add these and make that work. So I'm going to assume that there's no way to get an invalid number here. Actually, I suppose that's not true. If the first or second is an invalid number, then our result should be an invalid number. So what we'll say is if first dot invalid number or second dot invalid number. So if either of the two numbers are invalid, then our result will be invalid. And I put this at the top because I don't want to actually do the addition if that's the case either, because if my two values are actually invalid, then I think it would be not a wise idea to actually go and try to do math with those, because who knows what we're going to get. And we might even get a seg fault, who knows. So if these are invalid, then we will just return the result. That should be good. Because result by default is already marked to be an invalid number. So I think that's all right. Right, so could we make this a little more efficient? I think that's all right. Right, so otherwise we'll set result dot invalid number. Actually, yeah, let's do it this way. What I'm going to do is I'm just going to set it to this. And then we'll say if the result dot invalid number. Right, so if either of the two parents are invalid numbers, this will get set to true, otherwise it gets set to false, and then we'll just check if the result is supposed to be an invalid number, then we'll return it. Right, so I think that's good. That's maybe not a whole lot more efficient, but I think it's easy enough to read. Let me just move the comment up so maybe that's easier to see. Right, and then I don't have to accommodate for setting it equal to true because it's already done. So if that's the case, then I'm going to need to set the result array. So let's just say int. Actually, I don't need an integer. We'll just set it directly into the thing. So result dot length. And we want it to be the bigger of the two numbers. So if I'm adding two numbers, then my result is going to be at most the length of the longer of the two numbers, if not one more digit if we have an extra carry at the end. So what I'll do here is I will say the length of our result, that's a misspelling, of our result is the longer of the two numbers. And I'm just going to do that in one line for the sake of readability. So if first dot length is greater than second dot length, then we'll return first dot length, else we'll return second dot length. And so the ternary statement, right, asks, is this Boolean expression true? If so, return the first thing. If false, return the second thing. So really it's just like an if-else statement, but condensed to one line. Again, for readability, I don't write it too often in class, but I do use it pretty often when doing actual programming, because I think it's nice. Okay, so that takes care of that. The length is set. Now we need to do the actual addition. So I'll do int I, j, k, and these will be indices for the first, second, and result respectively. So I'm going to create 3 indices to traverse all 3 of these numbers, being this one, that one, and the last one. Actually, you know what? I'm going to just create one. Let's just do it this way. So add to the result. I could do it with 1. I can manage. You could do it with 3, and I think it would be maybe easier to read, but or maybe not easier to read. I think this will be easier to read, but the other one would be maybe easier to reason out, just inherently. But I'm going to do it this way. I guess one thing I should do. But first and second might be different numbers, or different lengths. So let me rethink this. Do I need all 3? Yeah, let's do 3 indices. Let's go back to what we had. I think it's easier that way. I'm sure I could fudge the addition somehow, or the arithmetic somehow, but we'll do this. So this one will represent the first length. This one will represent the second length, and this one will equal the result dot length. Okay, so we'll just keep track of all those, and then we'll traverse at the same time. So we'll say while k is greater than or equal to 0, so while there are still digits needing to be calculated for the result. And then down here at the bottom, I'm just going to do I minus minus j minus minus k minus minus. So each of these is going to start at the end of the list. In fact, I should probably do it as -1 for each of these. And traverse all of them. So this is going to go through the first digits array, this one's going to go through the second digits array, and this one's going to go through the third digits array. And I think that's all right. One other thing I need to do is I need to actually allocate the digits. So digits equals new character, and we need it to be result length. So allocate the digits for the result. And we'll just allocate that based off the length that we found earlier up here. And now we should be all set to actually do the addition. So I think two other variables I'm going to need. I'm going to need an int carry. That's it. I think I'm just going to need a carry. So we'll keep that, and I'm going to initialize that to 0. So if I did like 1, 2, 3 plus 4, 5, 8 or something like that, then the first step would be 3 plus 8, which is 11, and we would need the carry to be 1 and add that in the next step. Is the way addition usually works when you do it by hand, right, in like elementary school. So I think what we'll do is we'll set that carry, and yeah, we'll just do that and we'll add it every time. So what we'll do here is we'll set result dot digits sub I is equal to, oh, it's just result, and we'll set this equal to the first dot digits sub I. So actually, sorry, this should be a k. K was the index that we're using for the result. I is for first and j is for second. So I'll use I to access the first, k to access result, and j dot digits sub j. And then the problem is that these are in ASCII. So I actually need to, if I want to convert them to a number, I need to subtract by 0 and subtract by 0. And then we'll add the carry to it. So convert the first and second digits from ASCII to decimal and add them. And then we'll apply the carry in there too. And I could optimize this a little bit and add a +0 at the end and then make this cancel somehow with some algebra, but we'll keep it like this. It's not that big of a performance hit. It's just, maybe easier to read. Right, so we've actually added the digits now, and then what we need to do is we need to get the next carry for the next step. So the carry will be equal to result.digits sub k. So we're using result.digits to store the current actual digit that's going to be there. And right now it's in decimal because we haven't converted back to ASCII. So subtracting by 0 is going to convert this from ASCII to decimal. Subtracting by 0 here is going to convert that from ASCII to decimal. And the carry is already in decimal because it's an integer. So it's not really ASCII to begin with. Which means that the result is also going to be in decimal if all three of these things are in decimal. So what I'm going to do is keep the carry, which is also, again, in decimal. And I'm going to base it off of this. So I'm going to take the result, and if it's greater than 10, then I want to carry, and if it's less than 10, I want to not carry. And the easy way to do that is I just divide by 10, because 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 divided by 10 are all 0, which means the carry is going to be 0. Once it hits 10, 10 divided by 10 is 1, and 11, 12, 13, 14, 15, 16, 17, and 18, and I guess 19, are all, when divided by 10, are all 1. And the highest we can ever get when adding two digits and a carry would be 19, because that would be 9 plus 9 plus the carry, which is 1. So that takes care of that. It's way faster than an if, so that's why I do it. But you could do an if check where you check if it's greater than 10, set the carry equal to 1, otherwise set the carry equal to 0, or do a ternary statement or something like that. But this is more efficient because if statements are actually a little slow, and the computer can actually end up, when it tries to optimize your program, end up doing things ahead of time and then kind of having to backstep if it messes up an if. So I try to avoid those if we can find a mathematical solution, which this is. And then likewise, with this part, if it is greater than 10, then we don't want to store greater than 10 in a single digit, because that doesn't make sense in the context of numbers. I mean, when you're doing decimal numbers. So what we're going to do is we're going to mod it by 10, which will reduce it to a number between 0 and 9. It will remove the 10 in front, and then I'm going to add 0 to it to convert back to ASCII. So get the carry if number is greater than 10. And then here we will we'll say clear any number greater than 10, and we will convert back to ASCII. So this part converts back to ASCII, and then this part will clear the 10. Again, if you have a number that's 10 through 18, then modding by 10 will give you a number that's 0 through 9. And if you have a number that's 0 through 9, you mod it by 10, then you still get 0 through 9. So that will just remove the 10 if it is there without using an if statement, so it's faster. And that's good. So slightly more optimal, and that would be about it. So there's a problem with my code right now, which is the fact that this part up here is not always going to work. So what I'm going to do right here is move that down. So what we need to do is check if we're allowed to add the 2 places. So if number 1 and number 2 are not the same length, then this will not end up working, because I and j, one of them might be out of bounds. If, let's just say, I, or first was like 10 long and second was 3 long, then once we get to the fourth number, then j will be -1 and I will be something like 6 or something like that, which means that j is now out of bounds, and we are either going to access memory that we're not supposed to be accessing, which is going to give us some sort of garbage result, or we're going to get a seg fault. So either one is totally possible. So what I need to do is account for the fact that if one of them is shorter than the other one, I need to actually go and do that. So again, I could kind of just write this all in one line with a ternary statement, but let's not do that, because I think that's going to be way too long and maybe a little too much for now. So let's do this one with an if statement. So if we say that I is less than 0, so if first is out of digits, don't add it. In which case result dot digit sub k will be only based on the second digits and the carry. Right? And we'll say else if j is less than 0, which would be if the second one is going to go out of bounds. In that case, then I only need to add the first number, because then the second number is out of digits. And again, we do need to add the carry in there. That's required regardless. And then we'll say else. And then maybe I'll move this up here to there. And I'm sure we could do this slightly more elegant with like a ternary statement, but I think that's okay for now. Right, so if the first is out of digits, then only add the second. If the second's out of digits, only add the first. Else, if they both still have digits, then we add them both. And the nice thing about this is that they both can't be less than 0 at the same time, because one of them is what k is based off of. K is either equal to I or equal to j, whichever is the longer one. So that prevents us from from getting a scenario where both of these are true, so this logic should be alright. Now, there's only one extra thing I think we need to care about here, which is if I had a number like 506 plus, let's say, 603, then this is equal to 1109, which is one longer than the actual current array. Because the longest out of these two is 3, but the result is 4. And that will happen if 5 and 6, so if the two last values end up causing us to carry, then we're going to get a bigger number. And consider that that would still be true if I had something like this, where maybe it was 83 and then this was a 6, then the carry is still going to cause this to go out of bounds. So we don't want to base this off the lengths themselves, but I think the easiest way to do this is check if the carry is 1. So if we still have a carry at the end, then we need to append it. So in this case, the array is not going to be long enough. We need to make a new one and throw the one to the front. So what we'll do is we will say we need to get a new digits array for result now, right? We need to overwrite it. So what I'm going to do is create a character pointer, and we'll say new array, and we'll set that equal to new car results dot length plus 1. And then we will say that new r0 is equal to 1. So put the carry at the front, and this is in ASCII, so I should make it a character. And then copy the old array over. So we'll say for int. Actually, I already have I, j, and k declared, so we'll just reuse that. For I equals 0, I less than the result dot length, I plus plus, and then we'll copy everything into the new array. So new array sub I is equal to the old array, which is being stored in the result digit sub I, our new copy, and then what we'll do is we will delete result dot digits, reallocate the old array, and then we'll set it equal to the new array that we made. Copy the new array over, and this should avoid memory leaks, and now result is set, and we can just return it. Alright, so that one was kind of hard, I think. That was definitely the bulk of the program, was the addition, and now we got to do the subtraction, which is going to be very, very similar. And we're just going to have to do a little bit different, but I'm going to pretty much do this the same way. So let's just copy and paste a lot of this code. So we'll copy this, paste it down here. I'm going to probably do the lazy implementation for part of this. So a lot of this same logic seems to still apply. We're going to need some sort of number to return. If either of the two things are invalid, then we know that this is going to be invalid. We also need to worry about if we get a negative number. So if the second is bigger than the first, then we're going to have a problem here. Now the problem with that is that we would actually have to go through and check each individual thing, and I would probably want to write like a helper operator overload for that. And maybe I just don't want to do that right now. So I think the easy thing to do, which will work for now, is just check if the second is longer than the first, then we're done. We can't do anything if the second number is longer than the first number, because that means that we're going to get a negative. We should double check, I guess, to make sure that's all right in main. I think it is. So I have n1 minus n2, which is fine. If it does n2 minus n1, I'm going to have to actually write it. So, okay, maybe we are going to have to write this. What I'm going to do is just add some extra code here that we didn't actually put in originally, but I think will be helpful, which is just I'm going to write a less than operator, and I'll have that figure it out, and then I can just reuse it. So Less than is going to return a boolean, and we want it to take two things. I probably want it to be static. So what I'm going to do is I'm going to write a friend operator that returns a bool operator, and we're just going to do less than. We could do greater than and greater than are equal to, but I think that's okay. Right, so we'll say that's all right for now. Okay, so this will take a big num ampersand well, this should be const, so it shouldn't modify the arguments. Const big num ampersand. Okay, that way I think it could just make things a little bit easier to read. And this is a friend, so I guess I don't need that. That should be all right. Right, so I'm just going to make a new operator that works here. I think this is easier. Otherwise, we're going to have a lot of code in minus. Right. So we need to tell if less, or the left is less than the right. So if left dot length is less than right dot length, then we know immediately we can return. Else if right dot length is less than left dot length, then we can return true. And then else we have to actually find it. So if left is shorter, it's smaller. If the right is shorter, then it's smaller. And if they're the same, then I actually have to go through and do some actual calculation here. Right. I can actually write this a little bit better. So we'll say instead if left dot length equals right dot length. So if the two digits or two numbers are the same length, compare their values. And then what I'll say here is else, and then what we'll do is we'll just return left dot length is less than right dot length. That way I don't have to return true and false directly. I can just return the evaluation from this less than operator. So if the left is less than the right, then we know that this is true, that the left is smaller than the right. But if vice versa is true, then we know that this should return false. And this won't execute if they're equal because that's what the first if condition does. Right, so that should be a little bit easier to read and also way more efficient. So that looks good. Now we need to actually do the comparison. So we need to start at the beginning of the array, which is 0. So we'll say for int I equals 0, I less than left dot length. So it doesn't matter, they're both the same length. We can use either one. And then we actually have to do some calculations. So we'll say if left sub I is less than, well, actually we'll do the same sort of thing here. If left dot digits sub I is equal to right dot digits sub I, then these are the same. Then we should do nothing. So I guess I want to do this the other way around. Not the same, then one must be bigger. In which case we'll say we'll return left dot digits sub I is less than right dot digits sub I. So if we happen to find characters that aren't different, then we will just return the difference between those two. So if the left digit is less than the right digit, then we know that for sure the left one is smaller, and then vice versa, the right one must be smaller. Otherwise, if they are equal, we'd have to check the next digit. So if I had something like 1007 versus 1284, then these two ones right here would be the same, right? So what we need to do is keep searching through the array, so I'd need to wait until I hit the next spot to actually do another calculation. In which case something like the 2 and the 0 would be not equal, like up here, and then we would base it off of whether the left, which would be this one, or the right, which is that one, is bigger. And then what I should do is, just in case they are the same number, I should just return false. So that would mean that they are equal, which means that it's not less than, and we'll just say that that's not strictly less than, which is false. Right, so I think that is all right. This should help us here in minus now, so I don't have to write quite as much code. So if result.invalid number, and we'll also say or first is less than second. Cool, so now we condense that to one line of code. I don't have to write everything. So if the result is invalid or negative, return invalid. And then we need to set, as for the last one, we need to make sure the length is the longer of the two, and then we'll worry about the extra case again at the end. So we want it to be the greater of the two, and then I'm going to create 3 indices to look through all of these again and start at the end. And then we allocate the array. Now, one thing I should do is, second is a constant, but I kind of want to be able to do like some borrowing, because you do that in subtraction, right? Like if I had 128 minus something like 99, then 8 minus 9 is not doable. That's a negative number, so I need to borrow from here, turn this into a 1, and then make this into like a 18, right? And I do 18 minus 9, and then I would do the same thing here, where I get the 1 is invalid. I need to go and borrow from this place, so I turn that into a 0, and then this would become 11, and then I subtract that way. Now the problem is, if I do that borrowing and I replace my results array, then that's going to change the value of the second results, which is not what we want. We can't modify anything because it's a constant, and we really shouldn't, because when you subtract two things in a program, you don't really expect the compiler to go and change one of your values. Like if I did x equals 3 and y equals 5 and did x minus y, then you would be kind of angry if the compiler got back and made y like 12 or something just randomly, because that doesn't make a whole lot of sense. So what we need to do is we need to make a copy to work with and use that instead. So what I will do here is we will say big num copy equals, actually we can just use the copy constructor, so I'll just say second. So make a copy, I guess actually I want it to be first, so or subtraction. So that way if I overwrite anything, it doesn't happen in main. I've made a copy, which everything that changes will happen to that instead. Right, so everything else is the same. We have a index for the first number, an index for the second number, an index for the third number. We do that. Now the only difference here is that we need to do the same sort of thing, but this addition will be a subtraction. Now one thing I do notice is that I don't actually need all of these, I guess, because the first has to be longer than the second in order to actually add these. So what I'm going to say here is that the result length is equal to the first length, which has to be the longer of the two, otherwise this isn't going to work. So I can delete this and move it to a for loop. I think that's fine. So the first must be longer than the second, or it must be equal at bare minimum, otherwise we can't do the subtraction in the first place, because I mean the second is bigger than the first. So that should be okay. We'll make a copy of this. We'll set the length equal to the first length because we know it's got to be longer. And then we'll just use one index to roll through things. Now I might actually need another one for the second thing if they're unequal. Yeah, I do need something here. So I'm going to remove the carry as well, just because you don't do carrying and subtraction, and we can borrow with that copy. So I'm going to actually make j and k, and j will equal to the first dot length. Actually, let's make this I just to keep consistent with the last one. And then we'll make j equal to the second dot length minus 1. Right, so what we need to say here is while I is greater than 0, then we'll need to work. So I'm just going to use 2 here. I can use I for both the first and the result because they're both the same length up here. So while I is greater than or equal to 0, if I is less than 0, that can't happen, otherwise we're out of the thing, so we'll break that. If j is less than 0, though, that means that we've ran out of digits in the second to subtract with. So what we should do for that, so I need to make this I now, is just take the first dot digits, and that's it. I would be subtracting by 0, right? If I had things that didn't line up, like 1119999 minus 7, then all of these things are subtracting by 0. I could like throw zeros in front of these. I don't need to subtract by anything if there's no digits to line up. So what I'm going to do is just set that, and I think that should be all I need. So let's check. Let's just straight up copy it. We don't need anything extra. I think that's all right. Otherwise, if they are actually subtractable, like they line up, then we should actually subtract the 2 of them. So I'll take the first, and I will subtract the second, and then now we have no carry. Right. So one issue here is we might get a negative number, which is not supported by characters. So characters are unsigned, I think, by default. Maybe you can do an unsigned character. Actually, I think characters are signed in C++. Which seems strange, but I think that is a thing. Regardless, I'm going to try to avoid getting a negative number just in case. Let me remove this carry really quick. Let me remove all this stuff. We don't really need it anymore. So what I should check is so if the first is less than the second digit, so if the first digit is smaller, we need to borrow. So what I'll have to do there is I will need to say that first... Oh, I'm making a mistake. Again, I said I made a copy here for a reason. So what I should do is actually use a copy. Let's replace first with a copy really quick. Yeah, we'll end up getting a mistake here because I wouldn't have been allowed to do this next line that I'm about to write. Right, so what I was going to do was I'm going to say that the first dot digits sub I, I'm going to add 10 to it. Right, and then I'm going to borrow that from digits sub I minus 1. That should be good enough. So we'll borrow the 10, we'll add 10 to the current place, and then I should actually finish writing this, and then we'll borrow the 10 from the next place. So borrow 10 from next place, and then add 10 to current place. And then we just do that before we actually do the subtraction. That way we avoid having any errors before we get to that point. So that should be all right now, and I don't have to worry about this going out of bounds because if the first is bigger than the second, then I can't really borrow to become a negative number, and I can't borrow in the first place. Otherwise, I was going to get a negative. So I shouldn't get any sort of sig fault there. Right, so that should take care of everything now. And the last thing we need to worry about is removing leading zeros. So remove leading zeros. So if I had something like 456 minus 78, then that would be, so 6 minus 8 is, this would have to become a 16, right? So this would be an 8. We'd have to borrow from here, make this a 4. 4 minus 7, we'd have to borrow. 14 minus 7 is 7. And then I would have borrowed from here, so this would have been a 3. Now that's not what I wanted. Let's say this was a 452. Yeah, that probably makes more sense. So this is obviously just 4. And it would have 2 zeros in front of it because the 4 and the 5 minus each other are 0, and maybe in some cases I would borrow and still get that same sort of thing. Now the problem with this is that the length is based off of the first length, which is the longer of the two. And I might end up getting extra zeros in the beginning, but this will throw off my calculations later because the length of 4 in reality should be 1, but we've set it to currently be 3 because, I mean, that's just the way we thought it was going to work out. So we need to adjust for the fact that we might get zeros in front. So what we'll do is we'll just say int count equals 0. I could reuse I guess, but let's just throw this in there. So int count, and we'll say while the result dot digits sub count equals 0, we'll count plus plus. So what this will do is, while we don't have a 0 in front, we will increment how many zeros we've found. So count how many zeros are in front. And then what we'll say is if count is greater than 0, if there are leading zeros, then we will remove them by making a new array. So I'm going to do something similar to the last one where I just make a character pointer, and we'll say this is a new array, and it's equal to a new character array, and we're going to base it off the length of the result, and we're going to subtract the zeros from it. So make a new array with length not part of the zeros in front. And then we need to do a copy over, so we'll say for I equals 0, I less than. Right, so we need to actually, I guess in the thing here, this is alright. Let's just say it. So we'll go from I equals 0 to the length of the new one, which, let's just set that right off the bat. So we'll say, no, I think it's better to not. So let's just reuse this thing here. So we'll say, while it's less than the length of the new array that we just allocated, I++, and then we'll copy to that new array. So we'll say new r sub I is equal to, and then in the original we have result dot digits, and it's going to start counting at count because that's the first place that doesn't have a 0, plus I, and that should take care of that. And then consider that the last number here is length minus count, and this is count plus I, so we'd get result minus length, or minus count plus count, and these would cancel, so we'd end up getting result minus length plus I. I think that's all right. So say copy everything over, and then we just have to do the same thing we did before where we delete this. So we'll say delete the old array and then copy over the new one. And what we should also do really quick is result.length. Oh, you know what? I could have set this earlier. Let's move this up here. So result.length equals or minus equals count. So we'll remove the length. So we'll adjust the length to remove leading zeros. So this will be the length after remove the count of leading zeros in the front will be it without the leading zeros, and which means I can make this just result.length, and that should work all right. Now for the sake of efficiency, we can move that up here and subtract that too, and now we've got a few less operations. Right, so that should take care of that. That's all done, and then obviously at the end we need to actually return the result, and we should be good to go. Alright, so that was a lot of code. Let's see if it actually runs. And there are build errors. So operator function for that must return a value. Ah, right, so I need to return out. That should be it. Okay, my mistake. Now I should have a file somewhere on my computer. Finish running, that's good. Assignment 6 example. I should have a file somewhere. Programming assignments. Oh, this was assignment 6. Skeleton. The question is, where do I put this? I wrote a predicted output thing. We can see if it's actually somewhere in here. Oh, okay. I'll find it. It would be, I think I put it in, oh, I don't even have that anymore. I'm gonna have to open a separate thing. I put it in my thing that I use to run student code. So let me go to that directory really quick. We're gonna ignore that. That's somebody's code. Right, what I do need to do is go to this directory. Okay. So let's close this. That's main. I don't think it really matters if anybody sees that. Then I have predicted out. Okay. Alright, so let's just make sure this all matches. Zoom in a little bit, make it easier to read. So we have 456. So that none of this gets printed, it's the constructors. The extraction operator gives us 456 and 345. Addition gives us 801, 5433, 24629, 44535. That looks the same, invalid number. And then our subtraction is messed up, so we'll have to deal with that. It does get the invalid right, but it seems to have a mistake with this. Perhaps I'm just not converting back to ASCII because we're getting these issues here. Right. So there's that. We have invalid number. The insertion operator works, I think. It should. That's not too bad. The equal works. The not equal works. This might be messed up because of my subtraction. Who knows? The plus equal doesn't work. The plus equal seems to return something, and the minus equal doesn't work because our minus is broken, and then the copy constructor works. So I think these might be based off of a mistake I have with the minus equal. So there's definitely a problem with my minus. Let's see if we can fix that here and make it work. Now maybe it has something to do with the borrowing. We'll try to find out here. So minus first dot length. We have all this, and in two of the cases it didn't print anything, which was kind of worrying. So we'll see what's up. Now it's giving me this. That shouldn't matter too much. Result.digits minus those. Ah, yes, that is my issue. I'm not. Yeah, let's try now. I forgot to convert it back to ASCII. That still looks wrong. These still look wrong. So we clearly have an issue. So really quick, let's just throw something up here at the beginning, which maybe helps. So we'll throw this at the top, which says cout first minus second. and then let's do a run through really quick. Right, so we get there, enter, so we get 456 minus, I wrote the string second, not the variable. Very helpful, there we go. (456 minus 345). Now we know this one works, so I'm just going to continue and go around to the next one. And we get 111, which was right, and then we have 345 minus 456. Now what this should do is return an invalid number because first is less than second. So maybe there's an issue with my function. So it constructs the beginning one. It sets invalid number equals to first or second. These both should be valid because they're initialized. We go here and it will go and operate the less than. So if the left dot length is equal to the right dot length, which should be true, it goes and executes it. So for I equals 0, we get that. So it compares these. So if it's not equal, which they're not, 3 and 4 are not equal, then it should return the left dot digits is less than the right dot digits, which is true here, right? Oh, wait. Ah, I see. It's not returning that it's an invalid number. Right, so what I should do is add this to here. So if any of those are true, which I guess we won't think about the the short circuit evaluation, like the efficiency with that. We'll just worry about this. Okay, so now let me remove this, and we'll just see if it at least handles the invalid number part correctly. Which, oh yeah, I have it print a whole bunch of mess, huh? So it does the subtraction. This is 111. That says that's invalid, which is correct. It doesn't say this one is invalid, which is fine. We do need to subtract it. This one here is nothing. That's definitely an issue. Oh, I'm removing all the leading zeros, but if I subtract something by itself, I'm removing all the leading zeros, including the 0 that was there, so I need to address that. Okay, so that's a problem. And then this here, invalid number minus that would be invalid number. So I need to fix this, which will be quick, and then there's something up with this subtraction. Right, so that shouldn't be too hard to take care of. So we will say if result.length is 0, so if the result itself is the number 0, then we should return 0. So, yeah. We'll just say result.length equals 1. We'll just set it to copy over that last 0 instead, and then hopefully that'll work. Okay, so now let's see, we get square. That's no good. There might be something flawed with this to begin with. I guess we'll find out. Right, this will allocate 1 then. And it will go and set the one single thing to be... Oh, that does look like it's wrong. Right? No, maybe not. So 1. I might need a -1 here, because I'm working with indices. I'm just going to make a guess. We'll find out if that actually works. I'm not going to use all the brain power to make it work. Oh, it does seem to work. Okay. Sorry, that was a mistake on my part. This is an index, so we need to subtract by 1, but count is like an actual size, so that's where that issue should come from. This might go out of bounds, huh? And yeah, we'll say and count is less than result dot digits. Or sorry, and it's less than results dot length. That might actually fix this problem. Let me try this really quick, just out of curiosity. So if I do this, does it still print 0? Invalid number. No, it doesn't. Alright, well, whatever. If I made it equal, it might. Oh, but that might take fault, so I think that's alright. It's kind of janky, but. So that gets the 0 case. Now the only problem we seem to be having is with this subtraction here, in which case it looks like if it's borrowing. So we have 3 minus 2 is 1, 0 minus 3 is 7, then this would become a 4, right? Which it doesn't appear to do. So there's maybe something wrong with my borrowing. Okay. I'm making these go backwards, right? Okay. Result.digits sub I equals copy dot I. No, I don't see anything inherently wrong, but let's just go through, I guess. So let's go up here. We will maybe just run it when we get to that case. So we get this one, which we know works. We get that one, which we know works and prints invalid, and then we get this one. So let's actually go through and do the execution really quick. So once we get up here, we go through, we say if j is less than 0, which it shouldn't be, then we check the two of them. So what it's going to do now is it's going to check the 3 and the 2, and what should happen is 3 is bigger than 2, so it will just subtract the two of them like normal. So it will skip that if, it will subtract them, it gets that, right? And then we go down here, and it will say that the next two would be the 0 and the 3, and it should borrow, which it does, and we end up copying something over, so let's maybe do that and then look at it. So we get negative 51, that's not very good. Let's just make a thing for debugging. Let's make a character temp, and then we'll just use that as an intermediate. So I will set temp equal to this, and then we'll set this equal to temp. Okay. Yeah, let's try that. Okay, so I need to continue twice, and then we end up at the one that we want. And what I'm going to do is let's just go down here and take a look. So if I go to down here, we get the temp is equal to 1, which seems to make sense. 3 minus 2 is 1. We do the next step, and we get that temp is equal to 7, which is 10 minus 3, which is fair, okay. And then we go down to the next one, and we get that temp is 5. So maybe there's something up with digits. So I should actually write something all the way out here. Let's just see out copy.digits of I minus second.digits of j, and then equals, let's just put spaces here, equals temp, and then inline. So let's see what we're getting every single time. I need to remove that, go here, continue, and we get this. So let's just throw a breakpoint here again. Right, so for the first one it gives us 3 minus 2 is 1, which is correct, and for the second one it gives us something. colon minus 3 is 7. Now that sounds fair. I assume colon is 10 in ASCII. Maybe I want to convert these to integers to make this look nicer. And then the next one we get 5 minus 0 equals 5. Now it is apparently keeping that a 5, even though it should be borrowing. I might need to pull up an ASCII table. You know what would be easier is if I just converted these to integers. Oops. I'm going to need to subtract these by 0. Let's just move this to the end then. Right, that should be a little easier to read. So let's throw this out. And then we'll continue, and head down here. Okay. So we get 51 minus 50 is 1. It's still giving me the ASCII value. Does it have something to do with this? No, that's its own separate thing. Why is that actually an ASCII? That seems to be the issue. Oh, because I'm not modifying these, right? Duh. Yeah. Yeah, I do need to actually write that. That's annoying. Oh well. These are actually going to be in ASCII regardless, so I'm going to need to subtract that to actually do the debugging. Continue. We'll come down here again, and we should be okay. So let's continue, and we get to this position, and it says that 3 minus 2 is 1. Goes down to the next one, and it says that 10 minus 3 is 7, which is correct. This would be 10, this would be 3. Now the problem seems to be that it's not making that 5 minus 0 for some reason. So if I do the next one, or sorry, this would be 4 minus 0 because I borrowed from here. Yeah, so it's saying 5 minus 0. I know why. Because I can't take 10 away from it, it would be a negative number. I'm meaning to borrow 1 from the next place up. That would be what I'm messing up here. Let's just see if that runs correctly now. I'm going to throw out the breakpoint, and let's just see if it's correct. It does all this junk. 604, is that the right answer? That doesn't appear to be. Well, that's still no good. Oh, never mind. I'm not even at the right part. 111. Invalid number, 5 for all that stuff, and then 0, and then invalid number. Okay, that was it. I just made a typo, so that should take care of it. So let's just throw out all the extra debug print stuff then, just so we don't have it. I can throw this out. Oops, not that out. I can throw this out. We can replace temp there. We can just directly assign to it. Throw this stuff out. Don't need the temporary variable anymore. I'm missing a semicolon somewhere. That'd be because there should be a plus there. And now we should hopefully be good. So let's try one more time. Run it, and my plus is broken. Still for some reason. 456, 344, so it does that. 801, 5 that. 111 invalid, this stuff 0 invalid, all that. That's good. And then the plus plus is broken. And it's 913, which is a really strange number. That doesn't seem to be anything in particular. I don't quite know what that would be here. So we have plus plus. Let's go to main. So what are we doing plus plus on to begin with? We're doing it on number 1. And number 1 is equal to 456. Let's go here and see what happens. So if we go down here, we execute it, and we go into this function, then we do that. It should construct this thing, which is 1, and it should add these two together. So let's just see if when we go down here, then if we look at the results that it gets, some random garbage. 52, 4. Oh, 4 is the first number, which is right. Okay. I think I'm just going to need to see out it. Yeah, that wasn't very helpful. Let me go to operator plus plus. So we'll see out 1. We'll see out num. This is before we do anything to it. And then we'll do it afterwards as well. Okay, let me try running that here. So we go down here, we construct this, which is fine, and then we print it, and hopefully this should say 1, right? Okay, so it clearly it gets 1 correctly. It goes down to the next one, and it should print num before, and it gets 456, which it is. It's 456, and then it goes here, and we print it. Oh, maybe something strange with this copy constructor. Oh, I said num plus equals num plus 1. Duh, that's going to add it twice. We just want to do num plus equals 1. That would be the issue. Okay, let me just run the whole thing. Yeah, here we go. This looks more correct. So 457, 457, 346, 346, which is not right, but we'll fix that, I guess. And then everything else is right. Okay, so that was my issue. I just, I was not thinking. Right, so why is that? Why is this not happening? So here it should be 346. So this should be 345 first. Maybe I'm supposed to do it the other way around. Move this here, and then we'll return num plus plus. See if that one works. I guess I can remove this print now. Uh, 346, 447, 457. I'm still adding 1, which I don't need. 457, 457. I don't know why. I don't know why that's not working. Let's just do it this way. That should be baked into the syntax. Why? Hello? Why is it executing it out of order? The compiler handles the actual printing, or the order of this. So the one that's wrong is this one, I think, right? What it's doing is printing 457, 457, which is true because this should increment it before it runs that. This one should increment after it prints. So we print 346, 346. Let's see what the compiler is doing. Why? So it goes here, and it does plus plus, even though it shouldn't. Now, and then it goes to print it, which is not correct, and that's not something I control. Why is it doing that? That's super baffling. That's something that's baked into the grammar of the language, so I don't have control over that. The question is, why does it execute those out of order? I might actually just leave that in because I know that's not an issue with my code so much as it is with the compiler here. But the question is, why is it doing that? I've had issues with Sally executing things out of order. I've just never seen it do it in Visual Studio. Let me go to FileZilla and let's try running it on Sally and see if it's okay. And then on top of that, Black Swan sally.cs.unlv.edu. Let's go to Sally, see if it runs okay, and then I'm going to check for memory leaks while we're here, I guess. I'm baffled as to why it would do that. That's not something I think I can really fix. 6 example. So let's see, CS202 input. Throw this all in there. Did I already type in my password? Yeah, okay. S202/input. And then zoom in. Okay. Just gotta finish overwriting those. Alright, so I should have assignment 6 example, which is the code, and then I have the header file, which is the bignum.h, and then I have the text file that it needs to read it, so we'll say G++ assignment 6. And then I will run, let's just run it normally, and then I'll run valgrind afterwards. So here it still does it. Why? Did I write them incorrectly somehow? That actually makes no sense to me. It's not like it's asynchronous. I can't like return it and then do the addition. That's supposed to be part of the syntax. I'm super confused. Let's check valgrind while we're here. Just see if I did everything right. Yeah, okay, so no memory leaks. There's that, so we got that. That's good. Yeah, maybe spend a minute or two on this. I have no idea. Let me Google it. I don't know. C++ executing postfix operator before printing. Bug? No, nobody has anything. I'm not crazy, right? Like this is part of the the formal grammar of C++ is that plus plus, the postfix comes before, or it comes after prefix. Why? Why would that not work? Now, I can't put a number here, can I? That's not valid. Now it gives me this integer in the actual thing, which is the number that's supposed to increase by. Why would that not work? I can't just do this, return num, and then do it afterwards. It's not like it's like a coroutine or something. Now what this should be valid. Plus plus num. Return. Yeah, absolutely not sure on that. I guess I'm not getting 100% on assignment 6. I don't know. I'm doing something wrong. Maybe. I mean, that's legitimately that is not something I should have control over. Huh. I have nothing. I have no idea. I don't think I have a way to fix that. That's yeah, I don't know. I guess we're just gonna have to. I'm gonna have to take the 95 or whatever. And just say, oh well, it doesn't print the plus plus correctly. I have no idea. I'm gonna spend some time. I don't want to do it on the stream just because I want to pull open some student examples and just. I think most people wrote the same thing I did. So I'm not quite sure why mine wouldn't work. Maybe did I do something dumb with my declaration here? Nope. That's right. Yeah, I don't know. That's strange. Well, I guess we're just gonna have to end on a bit of an unfortunate note. My program doesn't fully work, but everything else does. And I was thinking it was something to do with the compiler, but Sally prints it wrong too. And you cannot change operator precedence in C++ because it is part of the syntax, like the actual grammar that defines the syntax. So I will have to look into that, see if there's actually a reason why it's doing that. Perhaps it has something to do with the copy constructor. I'm not really entirely sure why that would do something like that. Well, I don't think it's something to do with the copy constructor because it's clearly executing the postfix operator before it's doing the extraction operator, which it's not supposed to. The compiler shouldn't do that. So I don't know. I'll have to take a look at it. But anyways, I'll post it on Canvas with or without that fix at some point. And yeah, I guess that was assignment 6. Definitely took a lot longer than assignment 5. I spent, I guess, a little bit too much time on that subtraction because I messed it up. But